Good morning, good afternoon, and good evening, depending on where in the world you are today. Thank you for attending our Versa Network Software-Defined webinar series. Today we'll be presenting on branch as well as WAN segmentation to discuss protecting the business actually utilizing SD-WAN. Before we get into the presentation today, I just want to go over a couple of housekeeping items. If you have any questions during the webinar, please submit it using the Ask a Question button located on the top left-hand side of the player. Your question will be addressed during the Q&A at the end of the presentation. There are additional resources for you to check out in the Attachments tab at the top of the player. And you can also download the slide deck from this presentation at any time, as well as any of the other resources that you see there. At the end, please take a moment to rate the presentation and provide any sort of feedback by clicking on the Rate This button on the right-hand side of your player. And finally, a recorded version of this presentation will be available utilizing the same URL immediately following the conclusion of our webinar today. So with that, I'm Robert McBride, Director of Enterprise and Telco Solutions, and today I'm going to discuss with you branch and WAN segmentation. So let's go and get started. So first things first, of course, is that, segmentation isn't new. We've been doing this for quite some time, actually, many years. And we've been doing it through a variety of different ways. Either you're looking at it from the branch, the WAN, LANs, as well as data centers, but some common methods for segmentation are around VLANs, of course, IP subnetting, ACLs to do preventative communications between groups, VRFs to do some other higher-end segmentation there, and of course, separate physical infrastructure on a kind of per grouping basis. All of it, of course, the main goal of segmentation is to isolate the access as well as communications between groups, and however you define those groups as to being either organizations, departments, lines of businesses, sets of applications, groups of users, or even zones for that matter. But at the end of the day, segmentation actually isn't new, right? So, let's kind of move forward and actually kind of see where we want to take this. So, as we talked about, why we want to segment and, potentially some methods of how over the years we have been segmenting, what are we actually needing to segment? There are some things that are changing as a result of, just the way that our applications and, cloud access and various other newer things, if you will, coming about. They've kind of changed what we need to segment. But in a broad stroke of the pen here, we can take a look at roughly 5 various different categories that are common for things that need to be segmented from each other or from the mainline network. Of course, lines of businesses or departments. You can have universities that have various different departments that may need to or want to segment the means of access as well as communication. Obviously, lines of businesses. For example, in banks, you may have the actual retail side of the bank, and then within that, you may have, mortgage financial services there, or loan services, and they want to have some level of segmentation from a networking perspective. Mergers and acquisitions, of course, they need to be segmented between the various different assets. They need to be firewalled off and separated from each other, especially if the assets are, of course, going to, or either to different acquirers or staying, and of course there's a split now as a result of the acquisition. There's just basically multiple tenants now, potential overlapping spaces is highly potential there. Multi-tenant services from SP infrastructure, of course, as well as even enterprise infrastructure that we can also kind of go into here in a little bit. B2B partner access, I equate this to things like IoT or more partner cloud kind of networks. Being able to, stand up and segment off a means of communication for, non-corporate asset, of course, but it being a partner, maybe monitoring sensors for any sort of, say, HVACs or anything on a manufacturing floor and things of that nature. And generically, we call out guest versus business services, but this is, can be things like, segmenting guest Wi-Fi from the main network, because obviously we don't want guests to get access into the corporate side. Or even just doing segmenting of guests or even partner wireless access or even just guest network access from corporate access. The main thing, of course, is that no matter what it is or the grouping, the logical or physical grouping of these entities, they all have different requirements as it relates to how they need to connect, what their means of access needs to be, what levels of security, potentially even what type of topology is necessary or that they actually need for various different applications, and of course compliance. So how have we actually done it? So this goes a little bit, one level deeper into our first slide. We were talking about VLANs, IP subnets, and VRFs. But, we can categorize it in roughly 3 buckets. Standing up separate physical infrastructure per, let's call them tenants or per segments. Obviously, this can be very costly depending on the size of the business and the size or the scale that's necessary for the number of tenants or number of segments. If we're going to be standing up separate infrastructure per segment, per tenant, that can be very, very costly and, of course, adds highly to a level of complexity as a result of the number of touch points now that IT operations has to deal with. However, one thing to do call out, of course, is that within a separate physical infrastructure approach, you do definitely have separate data as well as control paths on a per segment, per tenant, or even a per segment, per tenant basis. So there's a high degree of security there. Most common analogy there could be for those that may be familiar with, typical like federal or military-like type of networks, where you have various different classifications, and those classifications are kind of air-gapped, and that's as a result of having separate physical infrastructure for each. So it's more secure as a result of a separation between 2 different segments or tenants is data as well as control paths. Then we look at VRFs, very common approach. They're secure, but they can be complex in the way of trying to manage route tables, dealing with overlapping address spaces, configurations. The scale can also be an issue depending on the solution that's chosen, meaning the number of VRFs that may be possible with a particular appliance, router, chassis. And in most cases, it's fairly predominant actually, from a VRF angle, there's actually a shared control path. So although each VRF may have a unique or separate data path that can be defined with unique topologies and certain types of policies assigned to it, the actual control path is shared typically, right? You have a parent VRF or a home VRF or a main VRF, and then you have your subtenants, which are the other VRFs. And the other one, which is the most common, we've been all doing this for many, many years, right? The initial form of segmentation, of course, was use VLANs, and then punch that over to a security appliance. Of course, this is secure. In addition to VLANs, of course, is the use of ACLs to help with deeper packet-like kind of inspection firewalls to actually look deeper into our packets for other kind of security threats or just add extra security policies. But of course, there's also ACLs to just do preventative access at a networking layer. But this, of course, is secure, but it can be complex because now we're needing to deal with multiple touch of things from a configuration perspective. Change management can become very painful as a result of needing to do ACL management. If you have to add new statements, remove statements, then you have to correlate that to potentially new firewall rules. If you're adding new groups or new logical zones from a VLAN perspective or new subnetting, of course there's change that has to go all the way across the board. So it can be tough to manage. Obviously it's tried and true. It's secure, but again, it can also be potentially complex. Looking at it a different way, and this just shows us visually what I was just kind of referencing and talking about. So we'll go through this very, very rapidly. When we look on the first block on the left, we take a look at this, and this is just a branch. And within the branch, we have separate physical infrastructure for our various different tenants or segments. The examples being shown here on the first one on the left is, guest wireless or bring your own device or mobile devices going into this particular branch. And on the other, going up through its own secure appliance, a firewall, to get direct internet access. And then we have another one which requires maybe more of a traditional hub and spoke type of topology as a result of it being a point of sale system. And so that may be riding on its own separate physical infrastructure, then back homes into a central firewall at the data center, where whether or not, depending on the solution for the POS, whether or not there's internet access or not. The point of this here is that, there's two separate paths. Each path has separate infrastructure designated to specific types of devices and for a very specific purpose, or tenants, if you will, right? Tenants for segments. Public segments, or, public guest services versus, a critical asset like a point of sale system. When we look in the middle, we just readapt this to now, instead of having two different routers, we can potentially use a singular router. An Ethernet router is being carved up into multiple VRFs, where each VRF is then assigned to each of the individual tenants with the same method and topology here, where we still have security outside of the router in and of itself, and traffic, of course, depending on the topology, being punched over into the data center through a potential MPLS VPN link. What's not depicted, of course, is what we mentioned earlier, is within the VRF angle, between each of those two tenants, VRF A as well as VRF B, there, of course, is a shared control path that would be obviously owned in the data center. And then the third one, just very simple view of looking at VLANs, ACLs, as well as firewalls. We got three different tenants that are broken up into at a VLAN angle, utilizing ACLs to prevent, the users or devices from each of those VLANs from communicating to each other. A singular transport link through MPLS going through a firewall, which then has it, let's call it, chopped up in the sense to have policies individual to each VLAN, or a shared one large policy statement that's looking at each of those segments or each of those VLANs and looking at security from that angle. And of course, managing whether or not internet access is necessary. The main difference as we go from left to right, you go left, one can make an argument, say incredibly secure, less secure than, and as we move over to the right, things are less secure. And the reason why I say that in the way we've depicted it here, the differences between VRFing as well as from VLAN, VRFing, depending on vendor and solution, of course, can separate the grouping of the devices or within the actual appliance itself in separate memory spaces, separate routing tables. Things are a little bit more carved up securely from a VRF approach versus VLANs, where VLANs are just more of a collection of ports put together. And there's a lot of possibility of potential leakage or just shared tables, really is the point. There's more sharing of tables in a VLAN approach versus a VRF approach. Now, of course, the two can be combined. So, I'm preaching to the choir to most people who deal with security as well as networking. That there's been a variety of different ways in the past how to get here. But I think that there's one point that we can actually articulate, and is that, no matter which way, when you look at it from a branch of WAN, it just hasn't really been easy over the years. And the reason why it hasn't, right, as we look through the points here, is typically it's been, manually and CLI driven as far as how you want to configure your routers, your ACLs for the routers, how you want to map and drive your policy-based routing statements and deal with your choice of transport and how you want to choose your transport if you're using hybrid WAN or trying to. And then on top of that, dealing with security appliances. And then, of course, that is done on a per device, per site, per tenant basis, depending on how your solution is architected, and it can be incredibly painful if you have a very, very large network. And then as we've looked at what's coming around now, and actually has been for many years too as well, is now we're looking at more direct to internet as more as peer-to-peer, and this has been actually changing traffic flows. So most things aren't necessarily always needing to go home run into the data center to then be scrubbed and dealt with centrally to then get internet access from a corporate perspective. There are a lot of different things now that are happening where we prefer to have direct internet access at the branch locally, and then drive traffic specifically over to the corporate side through the data center from a central perspective for certain types of applications. So basically the main point there is we're getting non-centralized access is happening a little bit more. So this makes things a little bit difficult from a tenancy perspective as well as the security angle. Also because your point of inspection for scrubbing has actually been moved, either moving away from the data center from a centralized perspective and potentially now being distributed across every single branch. At least that thought process is there, or maybe even having more of a cloud delivered type of a model for security But the point is now you're having extra management angles, and it just, although it helps to facilitate, to make things a little bit easier, it can add a little complexity from a management perspective. And the main trends really about cloud and SaaS and BYOD are kind of starting to drive some of these things, and of course IoT and things like that. The third point, excuse me, is really about, how it hasn't been easy, and I think this goes for any sort of network, is that, it's very prone to vulnerability and making adhering to compliance very challenging. And that's actually because of the very first bullet that we see, which is centered around being manual and CLI driven. There's operator error, the possibility of operator error, fat fingers that go on with wrong configuration statements. Basically human error makes the network prone. Having more screens and devices, so this talks to overall sprawl, lots of devices, lots of different appliances that IT operations need to go and touch when they actually want to do any sort of a change. So even a simple one-line ACL statement potentially that may do occur across a 500-site enterprise WAN, you're having to now touch between 500, even more than 500 unique networking or security focused appliances, and that takes time. And you may have a lot of different screens depending on how many vendors you actually have, and so it becomes very, very complex, and it makes it more vulnerable to being out of compliance, and potentially even being more vulnerable to security threats as a result of mistakes, to the other bullet point that we were talking about. So, the obvious thing of where we're going to this is, of course, you want it to be easier now. You want it. There's got to be a better way, and the answer, of course, is that there is, right? But now is at a point as needing to look at different means of transport on a per branch perspective. There's a lot of different other types of networks that are needing to have access to your network. You have newer types of devices now, so the way that the branch and WAN is communicating, the types of connectivity and security that's necessary for them is changing. And so it should be time for change in actually how you look at how you want to manage or actually even secure your overall branch and WAN. And of course, you want it to be easier and better. And so, with that, the good thing actually here is, there's something very proven that's here to actually be the rescue, and that's software-defined WAN. We're not going to talk too much about what SD-WAN is. We do have one other webinar. You can learn a little bit more from a Versa Networks perspective. And there's a lot of information on our website as well as across the board from partners as well as even competitors that can actually just talk about the basic of what SD-WAN is. But ultimately, it's here to help things make simpler and be a little bit more intelligent about how you actually want to provide connectivity at the branch and across the WAN. But when we look at just SD-WAN, it's great, but you actually really want to have a secure SD-WAN. So let's go into what that actually means, and I'll show you here in a minute or two. From our point of view, or just in general, we can define secure SD-WAN as being SD-WAN with integrated security, so something beyond more just stateful firewall capabilities, because as you're looking at applications and looking at the various different types of transports, looking at potentially multiple segments and multiple tenants, the need to actually place deep level or next generation advanced security at the point of connectivity becomes important. And so securing SD-WAN beyond just encrypted overlays and multi-topology capabilities as well as stateful firewall can that be a huge value add to how you want to architect your enterprise WAN and branch. But looking at this here, one of the other aspects about being secure SD-WAN, if we look at this, is having an overlay, right, which is SD-WAN in general, but having it be unique, having unique topologies per segment, per tenant, as well as per VRF. So now we're starting to look at a very hierarchical method of being able to drive topologies. And I'll give you a network diagram here coming up that actually kind of gives you that point of view. Being able to do policy for both network and security on a per tenant or per segment basis. So not necessarily just a per tenant, where a tenant may have multiple VRFs or multiple segments, but being able to done it across the board, right? Same thing as it relates to data and control paths. Can they have, having separate data as well as control paths on a per segment and tenants and VRF basis. Multiple services from switching all the way up to application aware firewall capabilities. or full-blown UTM suite. Having a single pane of glass for operations, administration, and management with RBOC, the role-based access control, on a per tenant, per segment, per tenant and will segment basis. This obviously is necessary for multi-lines of businesses, M&As, multi-tenant services. And of course, the most important piece, or one of the other more important pieces besides the obvious of security, really is having contextually based dynamic path selection on a per segment and per tenant basis. So what this means is on every single tenant and within each of those individual segments, can they not only have unique topologies for them, can they not only have unique policies as it relates to network as well as security? Can they all have their own unique criteria or setup of the different types of L2 to L7 services that they want to use? Can each one of them be managed separately by a unique IT administrator and not be able to have others see what they can see? And can they actually have their application policies and the method how they're actually driving application traffic steering be unique to them at a very granular segment or VRF or tenant level? And that helps round out an entirely more comprehensive SD-WAN or a secure SD-WAN type of solution. So looking at a different view and just kind of showing some of the elements from a Versa perspective here. At the top, you got single pane of glass for control, visibility, analytics. That's also multi-tenanted with RBOC on a per tenant basis. You have actually at the actual edge, you have a multi-service and multi-tenant platform that's on a per segment and per tenant basis, can provide unique routing, SD-WAN security services. As we move forward, looking at a transport, dynamic path selection and optimization that's contextually based. So we're looking at this from a user, device, location, as well as application, but being able to take that criteria and being able to drive path selection policies on a per tenant and per VRF basis. Of course, any transport and any access to be agnostic. But being able to do on a per VPN, per tenant, per VRF, unique topologies. And of course, securing your direct internet access as a result of having security services embedded inside of the edge appliance, so you can actually secure direct internet access right there, right at the branch and right at the egress and ingress point of all traffic that needs to come from DIA. Moving forward a little bit here. So I told you I was going to give you a little kind of a deeper look into how and what we're kind of talking about here. So this is just a quick double click in. So what we have is we have a provider tenant, right? And the provider tenant here is actually this, lovely company called Toys Your Shop. So they're just a big, imagine them to being like a big brick and mortar or a big store that you walk into. And within this store, of course, you see not only their things that you can buy, right, toys, of course, and various different aisles and things and products that they have. But within there, you've got, potentially a photo shop or a place to actually drop off some photos to actually get them printed. You've got ATM machines. You may have some food kiosks like a Pizza Hut or a Starbucks inside. And so all of them potentially are tenants, and they're tenants to the actual My Toys Your Shop, who's the parent tenant here. And what we want to show the method of segmentation as it relates to tenancy and how and what you can drive on a per tenant basis from access and policy and features is we take a look at, here, My Toys Your Shop would potentially, as the main provider, configure, what interfaces traffic can be received on for their corporate tenant, which will be residing at the store. What instances can be used by them, number of bandwidth, how much bandwidth, how many sessions and things, some basic parameters as an example. But then, have some sub configurations associated to the tenant, right? What kind of traffic steering policies they want to use, what are their NAT rules, different DHCP servers and DHCP relays, security policies that they want to use. They want to use the NG firewall, UR filtering, AV, as well as IPS for the corporate side. And then we start looking at the other tenants, and they can then be even sub-configured there. So McBride Photos, although we don't depict it, as we're trying to imply that these configurations are available on a per tenant at that sub-level basis. So McBride Photos can have NG firewall. The ATM can have NG firewall and say IPS. as the security policies and security elements pertinent to them. And the only traffic steering policy they have is they want a hub and spoke based topology. So this just gives another double click in. Again, it's just building off the other one. But what it shows you is that, my toys, your shop, right, is the provider tenant. There's a corporate tenant in the store, and within there, they may be, or within the warehouse, what have you, they may need to have segmentation, right? Need to have further levels of segmentation, looking at things from a departmental perspective, right? Your common classic setup here that we talk about, software, engineering, and HR. But each one of those, as you see here, is they can all have their own provider delivered configs as well as their own tenant policies. So each one can have their own firewall, own UTM. Some can use IPS, AV. Some may want to do, software. The software group may want to have a full mesh topology, right, to make this up, right? Engineering may want to have a hub and spoke or a partial mesh. HR, so on and so forth. And then we look at the other tenants that also are co-located utilizing the same infrastructure, and we're looking at McBride Photos, right? They have their own firewall, own UTM, different app steering policies, as well as ATM. The ATM machine itself, of course, can follow suit with that. So the main point here is, of course, the full breadth of services that can be provided on a per segment, per tenant basis allows for a more secure means of connectivity, facilitating how you actually want to segment your branch and WAN. So as we come up closer here to a close here, there are a couple of things that you can ask if you're interested in SD-WAN, you're looking at SD-WAN as a project, and segmentation's on your mind because you need to segment. You need to segment your various different departments in your university. You need to segment your guest wireless services from your other store network services, whether digital signage to point of sale to just traditional productivity applications like Office 365 as an example, to being a PE and looking at mergers and acquisitions and acquiring and how you want to deal with those assets, right? So segmentation is critical to the overall enterprise WAN and branch, and luckily we have SD-WAN to kind of help make it a little bit easier how you want to manage as a result of the value prop of a singular controller, single pane of glass that can happen across most of the vendors who provide it. However, if you're really needing deep levels of segmentation and tenancy, there are a couple of things you could probably ask of your vendor and try to get a little bit more details to make sure that they actually work for you. So we'll just go through them very quickly. The first one is, do you support a single head-end for multi-tenancy? Obviously, this could talk to how complex or how much of a footprint is needed in order for me to support multiple tenants, and can you do this across the full entire stack from management, analytics, to even the controller infrastructure? Is RBOX supported across the entire spectrum from management framework to control to the device and even to potentially to the visibility or analytics tool? Are the actual edge appliances or either the hardware or the software, how it's being served and delivered to you, is it actually multi-tenant as well, right? Or is that the only thing that's multi-tenant and something else is not? Is the support of unique encryption keys on a per tenant, per branch pairing basis, is that supported, right? That helps to kind of just be very, very secure on a per tenant basis. You don't want to have shared keys between tenants. And more importantly, maybe you don't want to share that same key across multiple branches. Can you support full services on a per tenant basis, right? On a per or even per VRF, and we list some of those services there. Can you provide visibility on a per tenant basis? Can each tenant look at their own stuff and not see other tenant stuff and prevent other tenants from seeing theirs? And the last one really is an interesting one, is how easily can you integrate into brownfield networks? Meaning, as you integrate to and deploy SD-WAN, you got some older legacy networks. Typically SD-WAN gateway nodes are actually used to kind of help facilitate that propagation of routes, right, and information between legacy to new. But how easily can that be done? What's the level of scale there? Because as you look at from a multi-tenancy perspective, it can get very complicated and overwhelming from the number of sessions and things that have to be stood up between the PE router as well as yourself. So that's actually a valid question to actually ask of your SD-WAN vendor and provider. And so with that, I just want to bring this to a quick close and just kind of talk about the value benefits of a secure SD-WAN for you. You can reduce your infrastructure and circuit costs simply because of SD-WAN, as well as doing device consolidation. Of course, you can increase your overall bandwidth to address some other concerns you have as a result of a hybrid WAN strategy. Operations to automation, so as a result of single pane of glass, zero-touch provisioning, one-touch policy control, or just auto self-healing or dynamic adjustment, right? You have a lot of automation associated with how your branch WAN is being operated. Branch sprawl, as we already talked about, as far as device consolidation that could potentially happen depending on the vendor you choose, if they have integrated security or multi-services within their SD-WAN. Overall, SD-WAN can actually help you improve and simplify how you want to segment. And of course, we talked a little bit detail about what kind of segmentation you may want to look at, and how hierarchical or how deep and advanced that segmentation can actually go from a tenancy perspective. And of course, with that, obviously be able to drive multiple topologies, different types of encryption keys or different types of VPNs, different topologies per VPN, multi-tenancy or high degrees of segmentation can help you meet compliance standards. And of course, the simplified management framework of SD-WAN also helps you meet that, because now it's much faster for you to be able to implement change control and be able to make adjustments to address any sort of compliance issues, or never get out of compliance as a result of standardizing across your network. And with that, we've run out of time, unfortunately. So I just want to remind everyone here in the audience that, that you can post questions, and I will, we will get back to you as soon as we possible. And with that, please, subscribe to our channel. Go visit www.versadnetworks.com. Schedule a demo with us. We're very responsible on that. We'd love to actually come out and actually show you this when working, and just reach out to us. And with that, there are a number of attachments. Please don't forget, and reach out to us if you have any questions. And with that, thank you very much, and I hope everyone has yourself a great day, no matter where in the world you are. Thank you.